So in this note video, we are going to be talking about transformations of quadratic functions, okay? Now this can get super complicated, but we're going to make it really easy, but we have to use our calculators. So make sure you have a calculator on your desk, and you need to be following along with me, not just watching me, okay? Make sure you're actually doing it in the calculator and see if it matches, okay? So transformations. Before we even talk about transformations, the first thing I want you to remember is that the quadratic parent function, write this down with me. Quadratic parent function is y equals x squared. What that means is the most basic parent function, quadratic parent function, is y equals x squared. Okay? So, and all the stuff that we're going to transform, and transform is just we're going to be moving stuff around, comes from that equation. So we have this equation, y equals ax squared plus c. Basically, the a, that just means the number, that's the number with x squared, okay? What does the a do? Well, the a actually does two things, okay? So, if it's positive, so basically positive or negative. Okay, positive or negative. So if the a number, if the number that's with x squared is positive, it opens up. And if it's negative, it opens down. Okay? Sometimes when it's negative, we call that, just write this down with me and I'll explain it, reflected over x-axis. Okay? What that basically means, and you don't have to draw this, but if you had like a quadratic like that, and it became negative, well, negative opens down, right? So it looked like that, which basically means that's the x-axis, and it just kind of reflected over it. But for now, if you want to put opens down, that's probably good enough. When you get to algebra 2, you got to write that reflected over x-axis part. All right, so now, the second thing a also does is it makes the graph either narrower, kind of like skinny, or it makes the graph wider. Narrower or wider. Okay, narrower, that means it gets further from 0. The number with x squared gets further from 0. Or if it gets wider, it gets closer to 0. Closer to 0. Let me just show you what I mean by that. So, go to y equals. I'm going to clear out anything. Type in x squared. That's our parent function, right? So, right now the number that's with x squared is 1. So if I make that further from 0, like 3. 3 is further from 0 from 1. So 3x squared. Let's just see what happens. So I have that guy, that's my parent function. And then it got narrower. See how it kind of got narrower there? So that's because it got further from 0. But if I go to y equals, I'm going to keep the first one and clear that one out. Let's do 1/2 x squared. So alpha y equals enter 1/2 x squared. And just graph it in the calculator. You'll see that's my original guy. And then this is my new guy. And it got wider. So the number that's with x squared makes it narrower or wider. Okay? And then if I, just to show you, if I threw a negative in front of that, so I'm going to insert a negative. It's not only wider, but it opens down. It's negative, it opens down. It becomes negative. Okay? Honestly, the a is the harder one. The c, what does the c do? The number on the back? Very simple. All c does is moves the graph. It moves the graph up or down. It doesn't make it wider. It doesn't make it narrower. It just moves the graph up or down. So just to show you that, so if I x squared, I'm going to clear that out. Let's say I do x squared plus 3. It's going to move it up 3, and you'll see that when I graph it. So there's my original, and here's my new graph, and look, 1, 2, 3. It moved it up 3. So the number on the back makes it move up or down. Same thing if I do -3, what do you think is going to happen? Is it going to move up? No, if it's -3, it's going to move down. So there's my original, and then there's my new guy there. Now, know what you might think is, well, that actually got wider. I know it looks wider, but it's just kind of like an optical illusion because when I actually move it down, it's staying the same. Okay? It only ever gets wider or narrower if the front number changes. But here's really important, and I would like circle this or highlight it or something. Best way to see changes is to go to y equals and graph them, and we look at them. So we're just going to go to y equals, graph, and look. That's pretty much going to be the theme of today. Go to y equals graph and look. So, describe how the graph of each function is related to the quadratic parent function. Okay. Yet again, quadratic parent function. That's just y equals x squared. That's all that is there. Okay. So, I could kind of tell you, look, this a didn't change, and it's plus 4, so it's probably just going to move up 4. But what I want you to just practice doing is go to y equals. I already have the x squared there. So x squared plus 4. And then I graph it. So there's my original, and there's my new guy. So it's not getting wider or narrower, but it did go up 4. So you're just going to write up 4. Did it become negative and shift down? Or no, just moved up 4. So up 4. So, okay. So B, let's do that one. And we're just going to do it in the calculator. So y equals, I have the x squared already. So I'm going to type in the new one, negative 2x squared plus 1. Do that with me. Go to your calculator, go to y equals, type it in. And then we graph it. This is my original. And this is my new guy. Whew. Okay, so there's a couple things happening here. First of all, it became negative. So you can put negative or opens down. This new one opens down. Or became negative, however you want to do it. Okay, that's the first thing that happened. Also, if I look here, that's my original. This guy got a little bit skinnier. Okay, narrower. So this one's also narrower. And I have that plus 1 there. It's kind of hard to see, but it did shift from 0 to 1. If I zoom in, just to show you that, that was my original. And this is my new guy. So that vertex still moved up 1. So that moved up 1. Boom. You're just telling me what happens. Now, C is a little different because on C, clear it out real quick. We have like some parentheses and stuff. So some weird stuff's going to happen, but I'll show you. We're still just going to graph it in the calculator. X squared is my parent function. So parenthesis x plus 5, close it, squared, minus 2. And then I graph it. And I'm going to actually zoom it back to normal. Hang on. If you ever have a weird zoom, like your graph isn't looking right, if you hit zoom 6, it'll go back to normal. All right, there's my regular. Woof, and now there's my new one. So what happened? It moved all the way over here. It actually moved left. And if I count it from 0, it moved left. 1, 2, 3, 4, 5. It moved left 5, and then it moved down. And if I count it, that's down 2. And that makes sense because of this guy right here. So this moved to left 5, down 2. Now, we might be saying is, well, Ms. Molina, in the notes, you never talked about moving left or right. You're correct. That's why this stuff can get super complicated. So I could really make it complicated and do it all by hand, or we could just graph it in the calculator and just describe the changes that we're seeing. Okay, so D. So y equals, let me clear that out there. So x squared is our original, and then 4x squared minus 3. So there's my original guy, my parent function, and here's my new guy. Whew. He got narrower and he shifted down 3, right? So obviously he moved down, and then I can tell it's 3. So he got narrower and down 3. Okay, so on this one, we have a bunch of different ones here. So here's what I'll do. I want you to pause real quick, and I want you to try to do these in your calculator. So pause and do them in the calculator. And then when we resume, I'll give you those answers. Do not just write down everything I'm writing down. So pause and try to do something. If you're listening now, I'm assuming that you have at least attempted these. So we'll do a couple together and I'll give you some answers. So this one right here, I'm just going to give you an answer. This one is narrower and up 1. This one is wider and up 2. Perfect. I'm going to do this one in the calculator for you as well as this one. This one should have moved left 1 and up 5. So there's a 1 there, sorry, and up 5. Good. And this one should have just been down 4. Okay. So I'm going to do 2 and 5 with you just so I can make sure you're seeing the same stuff that I'm seeing. So y equals x squared there. So negative parenthesis x minus 6, close it, squared. So I'm just typing it in. There's my original. And here's my new guy. So do you see that they're, obviously this is opens down or negative, however you want to write that. I'm going to put opens down. You can put negative. If you want to be fancy, you can put reflected over the x-axis. That's completely correct. It obviously moved right. Okay, so it moved right. 1, 2, 3, 4, 5, 6. Moved right 6. Okay? And it did not move up or down at all, though, because they're still right there on the x-axis. So that's still the same. So opens down, right 6. Number 5, same thing here. So parentheses, -2 plus x, close it, squared, like that. So when I graph that, there's my original, and there's my new. So I can tell it didn't move up or down at all. It looks the same width, but it did move right. So if it was over here, it did move right too. That's all that happened. So it moved right too. And guys, that's really all we're going to be doing today is just graphing and checking. Okay? But some of them get a little more complicated. Let's look at these challenge questions. I need to explain this so you understand what's actually happening here. It says sketch a graph where a of the function is positive and c is negative. Okay? So if a is positive, that means that the graph opens up. It's like this. Okay, and that's from this part of your notes here. So like right here, I said the a makes it positive or negative. If it's positive, it's opening up. Right? So if it's positive, it has to open up. But if c is negative, that means that the graph has to have shifted down. So if the c is a negative number, it has to shift down. So I'm going to draw myself a little x and y axis here. So I know it has to be opening up, but I also know if c is negative, it has to be shifting down. So anywhere down here, like you could shift down 2 or 3 or whatever. I'm going to shift down, but it still has to be a positive graph. Okay? So it could be that, or, because it doesn't tell us like specifics, it could also look like this. It could be super wide. I don't know exactly what it's going to look like. But it has to be positive, and if c is negative, it has to shift down. Really important, okay? So 2, if a is negative, so if the number in front is negative, that's going to shift down. Or not shift down, sorry. It's going to open down. If it's negative, it's opening down. What does c have to be for the graph to have 2 roots? So remember, roots means like rocks, roots, zeros, x-intercepts, or solutions, to where it crosses the x-axis twice. Okay? So let's just look at some options here. I'm going to do a couple graphs. Alright, so a has to be negative, right? So if it was down here and I did a negative graph, is that going to cross the x-axis twice? No, that's not going to work. What if it hit the origin exactly and it did this? That's a negative, but is that going to have 2 roots? No, it's just touching right there, just that one. So what if it's up here? So if I have it up here, do you agree that that's going to be a root and that's going to be a root, right? It's going to cross twice. So what does that mean? Down here, so if we shift it down, it's not going to work. If it stays at 0, it's not going to work. We have to move it up. Okay, so your answer is that c must be a positive number. C must be a positive number for that to happen. Okay? And I'm not saying that's super easy. That's why they're called challenge questions. But there you go. All right, flip it to the back. There's just 2 questions there. These are from a STAR test. They're kind of tricky, but actually really not that bad when we go over them. So it says here, the graph of f of x, remember f of x just means y equals. Just means y equals, so don't let that freak you out. Equals x squared is transformed to create the graph h of x equals 2 times f of x. This right here is will make kids get kind of like, I have no idea what's happening. But I will explain it to you. Which graph best represents f and h? Okay? All right. So we know that f of x is x squared. Okay? I can put that in the calculator. Y equals x squared. All right. H of x equals 2 times, and then don't write it, but f of x. Well, what is f of x? F of x is just x squared, right? So all that means is 2 times f of x means 2 times x squared. Because f of x is x squared. It just goes right there. Okay? So I'm going to graph these and see what happens here. So get your calculator. You do it with me. Y equals we have x squared. F of x is x squared. Clear that out. And then 2 times x squared for our next one. So here's our f graph. That's the first one. And here's our h graph. Okay. So we're going to look at our answer choices here. Did the graph shift up? No. Automatically f's wrong. Did the graph move to the right? No. Automatically h is wrong. So on G or F, so F's the same on both of these. G says that h got wider. H is saying that h got smaller. And what happened? This was our f of x line, and then this is h of x. It got smaller, right? It got narrower. So my correct answer is just J. And all I had to do is graph and look in the calculator. Okay? Graph and look in the calculator. This next one's a tiny bit trickier, but it is our last one, so you must be somewhat excited. Function P is in the form y equals ax squared plus c. Okay? If the values of a, so values of a and c, are both less than 0. Which graph is possible, basically? A and c are both less than 0. So if numbers are less than 0, do you agree that means that they have to be negative numbers? They have to be negative, right? Okay? So what happens if this a is negative? It opens down. It's a negative number. So that opens down, that does, but this does not. So automatically that's wrong. All right, C makes the graph move up or down. But if it's negative, it's going to move down, right? So if I'm here at 0, that one moved up by 1, so that's not right. It's at 0, this one moved down, so that one could be right. This one's at 0, and it's still at 0. I mean, it's negative, but it didn't move up or down at all, so that's not right. So my correct answer is H. So I know that's a little tricky because you have to think, okay, less than 0, that means negative. What's going to happen? Another thing that you can do is just kind of play around with some numbers. So I'm going to clear this out. If a is less than 0, just give me anything, like negative 2. Negative 2 is less than 0, x squared. And if c is less than 0, that's like minus 3 or minus 5 or whatever you want to do. I'll do 3. And graph it. It looks something like that, right? And the only one that looks anything like that is h. So you can kind of like guess and check a little bit. All right, that's transformations. Y equals, graph them, look and see what happens. So there you go. And then make sure, go ahead and go to your assignment.